In this lesson we're going to look at energy transfer during a chemical reaction in terms of the breaking and making of chemical bonds. To help us do that, we're going to have a look at the reaction between hydrogen and chlorine gas to make hydrogen chloride gas. Okay, and before we can go on and analyse the various bond breaking and making involved, we need to write out the symbol equation. And so you've got H2, hydrogen gas, plus chlorine gas gives you HCl, hydrogen chloride. It's not balanced at the moment, and all we've got to do to balance that is put a 2 here. Okay, and there we've got the balanced equation. So what happens in terms of the chemical bonds in order for this reaction to take place? Well, we can divide this into 2 steps. In the first step, the covalent bond of the hydrogen molecule and the covalent bond of the chlorine molecule have to be broken. And breaking bonds requires energy, so energy needs to be absorbed in order to do that. So this process of breaking bonds is an endothermic process, it's an endothermic change. Okay, so we've got the breaking of bonds and endothermic change. Let's look at the bond diagram. So first of all, we've got the hydrogen molecule, H2, that's got to be broken into 2 hydrogen atoms. That bond gets broken. And then we've got the chlorine molecule, Cl2, that's got to be broken into 2 chlorine atoms. Okay, and each of these bond breaking processes requires a specific amount of energy. In the case of hydrogen, it's 436 kilojoules per mole of hydrogen gas. Okay, so notice that that is a positive sign, which means it's endothermic, i.e. that we are absorbing energy to break the bond. In the case of the chlorine, less energy is required to break the bond. This is 242 kilojoules per mole of chlorine gas. And so, doing our counts, the total energy required to break the hydrogen and the chlorine molecules before the reaction can take place is the sum of these 2 enthalpy changes, which gives us 678 kilojoules per mole. So doing bond breaking calculations is really like doing accounts. So the first step involves breaking the bonds, and the second step involves forming new bonds, this time between this hydrogen atom and this chlorine atom, and this hydrogen atom and this chlorine atom. So as I just mentioned, in step 2 we're forming bonds. We're forming a bond between the chlorine atom and the hydrogen atom, and we do that twice because you'll remember that 2 hydrogen chloride molecules are formed in this reaction. Okay? The forming bond process is exothermic. Heat is released when bonds are formed. Okay, and again we're going to do our accounts, and so we note that when this covalent bond is formed, the energy change that takes place is minus 431 kilojoules per mole. As we mentioned in an earlier lesson, the negative means heat being released, means it's exothermic. And as I just mentioned, this happens twice because 2 hydrogen chloride molecules are formed, so the total amount of energy released in the bond forming operation in this reaction is minus 862 kilojoules per mole. So what we've got to do now to find the enthalpy change produced during this reaction is we subtract the energy released when the hydrogen chloride bond is formed from the energy required to break the hydrogen and chlorine bonds in step 1. Okay, so the change in enthalpy, that's delta H, is equal to the difference between the energy required to break the bonds and the energy released when the new bonds are made, which in this case is 678 kilojoules to break the bonds of the hydrogen and chlorine molecules and 862 kilojoules per mole released when the hydrogen chloride molecules are formed, giving us a total change in enthalpy of minus 184 kilojoules per mole. Just emphasizing again that the negative sign means that this is an exothermic reaction. That's to say, heat is released during the reaction.